So, getting to today's presentation, I'd like to introduce you to Aaron Loewen. He's a mechanical EIT. He's fairly recently graduated working at Westward Industries. When I was in industry, the perfect employee was somebody from a farm that had an engineering background. And you're seeing perfection here on the screen. I was always excited about that because they had the book skills, but they also were probably combining a field at 10 o'clock at night. It was going to rain in an hour and they had to finish and figure out a way to fix the combine in order to get it going. It's just a beautiful set of skills that people like that have. So yeah, with that, Aaron from Westward is going to run us through a presentation on Westward Industries and their driveline propulsion and how it's evolved over the last couple of years. So Aaron, if you want to take control.
Right. Hope you can see that there.
You bet.
Okay. Well, hello, everyone, and thank you, Ron, for that introduction. So as Ron said, my name is Aaron. I'm an engineer here at Westward Industries. And today I'll be talking about the evolution of our battery electric drivetrains and specifically about our project of integrating a new powertrain from Valeo into our Max EV line. So quickly, we'll go through the agenda of what we'll talk about today. So quick background on Westward Industries and our Max EV platform. Why did we choose this project? The project vision, an overview of the project. Then we'll get into some specifications and design considerations, and then the integration of that Valeo drivetrain, challenges we faced, successes we had, and then where we're currently at and what's next for us. So a bit of background on Westward Industries. We're a manufacturer of gas and electric utility vehicles based here in Winnipeg, Manitoba. The company was established in 1990, and in 2012, it was acquired by new ownership, one of which is Steph Franz, who I think will join us today if he's got time, but he's a busy guy. So a recent history of the company. So like I said, established in 1990 with the launch of the Go4, which was a task-specific three-wheel vehicle. You can see a picture of the original one there. And more recently, in 2013, we launched the fourth generation of the Go4, which would be the original platform for our electrification process, which began publicly in 2014 with the launch of the Go4 EV. Then in 2020, the Max EV was launched, which is a four-wheel low-speed vehicle, or LSV, originally designed for the last-mile delivery market. And in 2024, we began the project, which we're discussing today, of updating the powertrain in the Max EV by integrating the new Valeo e-axis motor. So our current lineup consists of the fifth generation Go4, the Max EV low-speed vehicle, the Max EV3, a three-wheeled version of the Max, which is designed for tighter spaces, the Max EV 4-passenger, and the Max EV off-road vehicle. And as of today, the Valeo e-axis motor powertrain has been rolled out to the whole lineup. Briefly, in case you're wondering, an LSV or low-speed vehicle, it's a street-legal four-wheeled electric vehicle with a top speed of 25 miles per hour and a gross vehicle weight rating of less than 3,000 pounds. So why this project specifically? For one, demand. We'd seen demand from our customers for increased functionality that our previous powertrain could not accommodate, as well as demand for what would be one of the first four-wheel drive LSVs in North America. Next, we have cost to consider. Like all OEMs, we have to reduce costs to be able to stay competitive in this environment. Related to that, we wanted to simplify our manufacturing. The new Valeo unit is a single integrated unit instead of a multi-piece assembly like we had before, which reduces the complexity and time of manufacturing. And last but not least, why we wanted to pursue the project was to aid in our transition to being a manufacturer of exclusively electric vehicles. And before we can accomplish that, we must have a robust electric drivetrain in place. So the vision for this project was to integrate a new powertrain that would enable us to provide a better quality product to our customers. We would do this by integrating a new single unit drivetrain from a top tier automotive supplier in Vallejo with increased capabilities to enable features that we saw demand for. We would also be able to develop a modular 4-wheel drive design with this drivetrain, all while simplifying the manufacturing process and reducing costs. So a bit of an overview of the project. This project was the integration of the 48-volt e-axis powertrain into our Max EV platform. This integration would require design changes to the chassis, subframes, drive shafts, control box, and wiring harness. And while making modifications to the designs, we also wanted to reduce the weight of any components we modified along the way. So the integration of the Vallejo system would also require software integration. For this, Vallejo would work with us to program, test, and validate the Driveline software for both the 2-wheel drive and 4-wheel drive options. The software would control parameters such as power output, regen, and new features such as hill assist, creep, and the control of additional electronic brake calipers for a hill hold function. Also not included in this project, but happened in tandem because it was convenient timing, and if we didn't do it then, we would have had to redo some of the same work. We also decided to update our batteries and other associated components such as the display and the charger port. So some key specifications regarding the old and new powertrains. The new Vallejo system is significantly lighter, 50 kilograms versus 22. The old system had a lower RPM limit on the gearbox. So for our higher speed application vehicles, we actually had to install a different set of gears. The new system can handle all of the speed ranges that our vehicles require. The new system comes as one pre-assembled unit, making assembly considerably faster and easier. Also, the old system required 2 different battery voltages, 48 and 72 volts, depending on the vehicle spec, and the new one just requires 48 volts for all of the options. And if you're interested, there's some of the power and torque specs in the corner there. So some key design considerations that were identified were obviously packaging, the available space we had to work with given the pre-existing vehicle design, as well as any requirements of the Vallejo system, for the Vallejo system. For example, there was a mounting angle requirement that we had to work with. We also had to consider any regulations applicable to low-speed vehicles, both in US and Canadian markets. Also, the power requirements of the new Vallejo powertrain. And related to that is reducing weight of the vehicle as much as possible, wherever there were changes to designs. And the cost of manufacturing parts is also considered, and trying to reduce cost and simplify those parts. And you might be wondering why we chose the Vallejo e-axis powertrain. So the key considerations that led us to choosing it were firstly that Vallejo is a top tier automotive supplier. So they would ensure that we'd get high quality parts and at a competitive price point. Unlike our previous powertrain, this system was designed from the beginning for use in vehicles. So that also had lots of features that we would like to use for that. Second, the system improves the vehicle assembly process in both speed and consistency by coming as one pre-assembled unit. And also, as mentioned before, the e-axis powertrain can spin to significantly higher RPMs, which enabled us to use it across all of our vehicle applications and remove the different gearing options we had to provide before. So the integration of the Valeo E-Axis powertrain into the Max EV. So the Valeo parts that need to be integrated were the powertrain itself, the DC-DC converter, and the PCU, all of which needed mounting and wiring considerations, and then also programming. The drive shafts needed to be sourced to fit the new Valeo system and our existing hubs, and the chassis and subframes needed redesign work to accept all of the new components and ensure everything fit with all of the options and accessories that we offer. So there's a SolidWorks render there that you can see what we were expecting it to look like. So everything was modeled beforehand using SolidWorks. Some components we were able to prototype using 3D printing, such as the belt cover seen on the right of the screen there, and some electronics covers. We were then able to use those to create molds for plastic vacuum formed parts. Harness design changes and manufacturing is all done in-house at our Archibald location. And the programming of the Valeo powertrain software was completed with the aid of Valeo. And I believe this was done both remotely, and they came out to do some work in person. So challenges. So some challenges we faced along the way were obviously general fitment and packaging issues were the name of the game, but specifically there were some challenges associated with the four-wheel drive system in the front. The Valeo system, like I said earlier, has a mounting angle requirement, which was a bit difficult to meet given the more limited space in the front of the vehicle, as well as getting the AC system to fit with the four-wheel drive option. You can see a photo of it in the top right there. It's pretty close. Specing the drive shafts presented some challenges too. We tried to source them from a supplier who supplies them for the Citroen Ami, which also uses this powertrain, but there was some differences that we weren't expecting, and in our initial test vehicle, the drive shafts fell out, which obviously isn't ideal. We also wanted to have a phased approach when it came to rolling out the new powertrain, meaning we wanted the old and new powertrains to both fit in the vehicle, just in case we came across an unexpected issue, then we wouldn't be dead in the water on our assembly line. There's also some challenges with the cable management for the thick power cables, specifically the ones running to the front of the vehicle for the four-wheel drive system. And once we got a test vehicle running, we ran into some challenges with power management and overheating that needed to be sorted out. And last, but certainly not least, there was definitely some challenges associated with the CAN communication in the car. So moving from challenges to the better part, successes. So in general, we were able to successfully integrate the Valeo E-Axis motor powertrain into the Max EV. And in the end, reduce both cost and complexity of the powertrain as a whole. During the design process, we were able to significantly lighten many of the associated components, as well as reduce unique part count by using more common parts in more places. Another success was the use of the 3D printed prototypes, which we were able to turn into full production components. And we were also able to add some of those additional software features that we wanted to at the beginning, such as the hill hold function, which we also installed a electronic caliper that you can see there. So as of today, the new Valeo E-Axis motor has been rolled out across the entire Westward lineup. And it's also available in a dual motor four-wheel drive configuration on the Max EV LSV, ORV, and 4-passenger models. So what's next? Well, we will continue our journey to becoming a fully EV OEM, with the next item on the list being integrating Valeo's next generation of the E-Axis motor powertrain, which will be a fully enclosed unit that is IP67 rated and will move from being belt-driven to gear-driven. So that will be neat when that comes out. All right, that's all I have for today. So thank you everyone for your time, for coming out. I believe we now have some time for questions. Or if you want, please send any questions to my email there on the screen.
Yeah, thanks, Aaron. That's really interesting. So with your platform, how do fleets charge the Max EV? Do you have an onboard 110 to DC converter, or what's your charging?
Um, that's a great question. I don't want to give you the wrong answer. I haven't been super involved with that, so I don't know for sure. I know that the DC-DC converter is 14 volt to 48, but I don't know the specifics.
Okay, okay. And with, like, you talk about transitioning to a completely electric driveline offering, which is fantastic. With what's going on in the States right now, I would assume that you're still selling gas units, correct?
Yes, yeah, we are. Yeah, in the Go 4, we offer a gas version of that.
Yeah. Do you find that market slowing or it's steady, or what kind of trends are you seeing?
I'm not super involved in sales, but from what I've heard, it's sort of steady. It goes up and down through the years, but it seems relatively steady.
Okay. Interesting. Interesting. If any of you that are online have a question, feel free to use the Q&A or the chat feature, and we can add that. Just curious, do you guys have 3D printing capability in house to do like the belt guard and stuff like that, or did you have to do that out of house?
Yeah, no, we have the capabilities in-house to do that.
Oh, okay. Okay. What other types of things have you 3D printed that
Oh, lots. So lots of small electrical covers. There's components in our dash and display. We offer a couple different options for display sizes. There's a small one and then a larger touchscreen one. So there's some bracketry and with those parts that we 3D print, and then lots of prototyping of small parts we sort of do casually.
Oh, interesting, interesting. So how big's the bed of your printer? How big of a part can you make, or is the belt cover pretty much the maximum size?
I think the belt cover would be pushing it. It's just the for those who know, it's the Bamboo Labs X1. So I think it's a 300 millimeter by 300 millimeter bed. It's so not huge,
Okay.
but we use it
Okay.
well.
Oh, good, good, good. So you'd mentioned earlier in your presentation about power management and some overheating issues that you had. I would assume that you're not liquid cooled anywhere. Everything's air cooled, right?
Yeah, everything is air cooled.
Yeah. So what kind of overheating issues did you have? What was happening?
Um, again, unfortunately, I don't know the specifics. Again, I've only been here a short time, so I wasn't very involved with this project, unfortunately, because I wasn't around. But I believe it was the thermal cycling of the batteries.
Oh, okay. Okay. Interesting. Okay. No, this has been really good. Again, last call for questions from the audience. If you have something on your mind that you'd like to ask, please feel free to post it in the chat or the Q&A. And I'm not seeing anything here, Aaron. So with
All
that,
right,
I
easy
would
days.
like to thank you for your presentation. And just mention again that if you're interested in any of the mission trips or the student engagement event we have coming up at Red River, please feel free to reach out to me if you'd like to be on the VTC comms list so that you're aware of uh, programs that we're running, mission trips that we're going on, technical sessions that we're hosting. Please feel free to fire me an email at rvanderwees@vtci.ca. So with that, I think we're going to end. Thanks again, Aaron. Thanks to the staff at Westward for presenting today.
Yeah, you're welcome. Thank you for your time and everyone else.
All right. Have a great day.
You too.